All right. So, hello everyone, and welcome back once again to our test three, which is this is the last part. And yeah, my God, I can't believe that we reached 7 parts. Don't worry. Next time we're going to reduce that. Okay. So, think of it this way as your practice. Okay. Forgive me if it's a lot, but think of it as if you're trying to practice. Okay. So we have two problems here. Let's start first this one. Suppose you are driving on a long road. The radius of each tire is 45 centimeters and it is rotating at 125 revolutions per minute. What is the speed of a car? You see, in getting the speed of a car, uh, usually they use this one. V is equal to distance all over time. Like what would be the total distance traveled and what would be the time duration. Okay? That's how they get the speed of a car. But there's another way. And what would that be? The speed of a car from their tire. Because tires are responsible for what? Accelerating the car. Hence, there is a speed of the car of it. Okay? So we can get the speed of a car by their tires. All right? So here's the thing. Uh, the speed of a car here, if you're asking me, was it linear or angular speed? It's still linear. Okay, it's still linear. Because you see, as the tires, revolve or rather rotate, because since it's moving by its own, you know, they're actually pushing the floor for you to move forward. Okay? Right? Think of it this way, like you're in a bicycle. Okay? Right? Bicycle has two tires. Right? We rotate the bicycle for it to move. By how though? By moving the bike into clockwise rotation. Because you see, this bike is pushing the floor at this point. Okay? Okay? Oh, no, 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 wait, wait. Let me fix the direction. Actually, yeah, it's like that, but it's like this. It's like it's pushing the bike away for you to move forward. Okay? So it is still a linear speed. By the way, I actually forgot to include that linear speed is just the same as tangential speed. Okay? Because remember, right, I told you the the reason why it's called linear speed is because of the perpendicularity of the radius of a circle. So that means that line, you know, line that is perpendicular to the radius of a circle is a tangent line. So that's why it's called linear speed. And tangent is also a line. That's why both of them are just the same. Okay? So linear speed and tangential speed are the same. But anyways, let's proceed. So yeah, this one, the tires, they're pushing the floor like in this direction just for the object to move forward. Okay, so that's exactly uh what's happening to the car for it to move forward. Okay, so here's the problem though. Okay, it's rotating at 125 revolutions per minute. This is actually your angular speed. Okay, because it's talk about rotation. So obviously by rotation there is an angle, but you see we have rev, which is what? Revolution. Okay, rev means revolution. By any chance, can we convert it into radians? Because you see, uh we can get the angular speed not only by radians actually, but also by revolution. So here, for us to find the linear speed, we're going to use this one. Okay, because we have the radius and we have the angular speed to find the linear speed. Okay, but you see, this is supposed to be in what? In radians. Okay, you need to convert this one into radians. By how though? Remember this one. One revolution or rotation is equivalent to 360 degrees, or in radians, 2 pi radians. So that means this is just the same as 2 pi radians. So 1 revolution is equivalent to 2 pi radians. But still, actually, no, sorry. It's still correct though, but how are we going to convert this revolution into radians? Now that we have this one, what we're going to do is to use dimensional analysis to convert the radians into, to convert the revolution into radians. Let me erase this one. Okay. So how to do dimensional analysis? Basically, it's like this. 125 revolutions per minute times a fraction, right? It's a fraction. So since we're looking for the radians, and we know that 1 revolution is equal to 2 pi radians, so we need to cancel the revolution here. So that means your revolution is on the denominator. Then the radians should be on the top. So revolutions are now canceled. What you have is 125 per minute times 2 pi radians. So what will be your answer here? The answer here is you will have 200, am I right? Wait, 10, 4, 5, yeah, 250 pi, pi radians per minute. So that is your angular speed, okay? That is your angular speed. Now we can substitute it here. So we have V is equal to your radius, 45 centimeters, times the angular speed, 250 pi. I have no space here. I'm just going to write it down. Radians per minute. Okay? So what would be the answer? Well, exactly. Wait. Exactly. This is 45 times 250 pi. Okay. There we go. This is exactly 11,250 pi. 11,250 pi centimeters per minute. But again, we need to approximate this one because in reality, once again, we couldn't measure this one exactly. But by approximate, we can do it. So approximately this is 35,000 342.92 centimeters per minute. So in 1 minute, the car can reach 35,342.92 centimeters. And yay, this is our answer. That's it, okay? Just remember, 1 revolution is equivalent to 360 degrees, which is equivalent to 2 pi radians. All right? Now here comes our last problem. Suppose you and your 2 friends, Marcus and Carlos, are running on a circular track. The goal is to survive as much as possible. So it's like you're running forever. In an exaggerate way. You get me? And then you're going to have a competition with your friends, which the 3 of you survive the longest. But yeah, okay. Anyways, the distances between you, Marcus's and Carlos's, and the center of the track are 10 meters, 100 meters, and 20 meters respectively. I forgot to put the word respectively. Okay, respectively. Okay? Once you and your friends are done, your speed and their speed are calculated. You achieve 3.5 revolutions per minute. Marcos achieved 4 revolutions per minute, and Carlos achieved 2 revolutions per second. Wait, no. This is supposed to be a minute. Oh my God. That's unrealistic. No, it's minute. Okay. What will your angle speed and linear speed be? And their angular speed and their linear speed as well. Seems like we have 6 answers in total. Okay. So your speed, their speed. Okay. So yeah, your linear speed, angular speed, and their linear speed and angular speed. Okay. So first and foremost, let's start with you. Okay. So according to the problem, okay, the distance between you and the center of the track is 10 meters. Okay. So that means your radius is 10 meters. Okay. You achieve 3.5 revolutions per minute. So that is your angular speed. Okay. Which is actually, this is your answer. You get me? So yeah, that's your angular speed. You get me? But if you want to convert into radians, sure, why not? Okay. In converting this one into radians is how? How though? Okay. So if you're going to convert your revolutions into radians, what you will do, 3.5 revolution per minute. Wait, this is R. Okay, whoa. Times, okay, we have what? 2 pi radians all over 1 revolution. Okay, this is the thing that you're going to do to convert that angular speed into radians. So yeah, you get your answer. Your answer is angular speed, which is 3.5 revolutions per minute. So yeah, now we need to find your linear speed. And by doing that, you need to convert this one into radians. Okay? So cancel out the revolutions. What do you have? 35 per minute times 2 pi radians. So the result here is that your angular speed is 70 pi radians per minute. So this is in angular speed. Okay? So now we're going to use this formula. So you have the angular speed, which is your W, and your R as 10 meters. So let's substitute. So your radius is 10 meters. Then your uh, angular speed is 70 pi radians per minute. So here, your answer is 700 pi meters per minute. So this is the exact answer, but we need to, once again, approximate because we have an irrational number. So 700 pi is equivalent to 2199.11. 2199.11 meters per minute. So this is the answer. Okay? Your angular speed is this one. That's obvious already. Okay? I already told you that when you have revolutions per minute, what is your angular speed? This one. It's still revolutions per minute. It's just that we never use radians. We use revolutions instead, which is still allowed for the what? For the angular speed. It's still okay. All right? But if you wish to convert it into radians, in fact, we need that to find our linear speed. So this is our answer. Okay? So that's for you. Now, how about for your friends? So let's start first with Marcus. Let M be Marcus. So his linear speed, what is his linear speed? It's what? It's 4 revolutions per minute. So good. Now, how about we find its linear speed? So first, we must know the radius. So the radius, okay, the distance between Marcus and the center is 15 meters. Okay, so we're good to go. Now let's convert it into radians. So 4 revolution per minute times 2 pi radians all over 1 revolution. So cancel out the revolutions. What you will have is, what you will have is 4 per minute times 2 pi radians. So this is exactly 4 times 2 pi. This is 8 pi radians per minute. Okay? So that is your angular speed in what? In radians. So we can now substitute it here in our linear speed. So we have a radius of 15 meters times the angular speed of 18 pi radians per minute. So here, exactly, you'll get the answer. This is 120 pi radians, no, it's meters since we're talking about linear here. So it's meters per minute, okay? But we need to approximate this one. So this would be 376.99 meters. Okay? 370, am I right? Okay, 76.99 meters per minute. Okay? So that's good. All right? Now, lastly, let's talk about Carlos. So for Carlos, okay, so I think you already know its angular speed. Okay? But let's start first with the radius. The distance between Carlos and the center is 20 meters. Then, yeah, his angular speed is 2 revolutions per minute, not second. That's so unrealistic. Unless he's the Flash, if you know what I mean, or Sonic the Hedgehog. But yeah, 2 revolutions per minute. So let's convert this one into radians so that we can find our what? Linear speed. So this is 2 pi radians all over 1 revolution. 1 revolution. So cancel the revolutions. So what you will have here is 2 per minute times 2 pi radians. So you will have 4 pi radians per minute. All right, so that's for Carlos. Now let's get the linear speed. So R times W. So your R here is once again 20 meters and the angular speed is 4 pi radians per minute. So the answer here is actually 80 meters. Am I right? 4 times 20. 80 meters per minute. Oh, no, 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 no. I forgot to include the pi. Forgive me, forgive me. I forgot to include the pi. 80 pi meters per minute. Okay? So that's the exact answer, but we need to approximate it. So 80, I'm assuming it's 120 plus. So let's take a look. 151.33. Wait, not 100. It's wait. It's 251. Okay, 251.33 meters per minute. Okay, meters per minute. So that is your answer. Okay, that's it. So we're good to go. All right. Wait a minute, Arish. Wait, I'm just double checking. No, wait, I'm just double checking about your what's that again? Your answer here. I forgot the linear speed. Sorry, I actually answered this one in a way that uh let me rephrase it. Basically, uh I answered this earlier. Yes, you know that. But as we proceed to the next part, I actually forgot what's the answer here. So, damn it. But let's take a look. Okay, for a while. Let me just take a look. Actually, oh wait, sorry. Actually, I'm wrong here though. Okay, let's solve this one once again because I could be wrong. So your angular speed is 3.5 revolutions per minute. So that's the answer. But we need to convert this one into linear speed. No, wait, radians. So what we did is we multiply uh, 3.5 revolutions per minute by 2 pi radians all over 1 revolution. So we cancel the revolutions and we multiply them together. You will have 7 pi radians per minute. So that is your angular speed, but in radians. Okay? Then we substitute it here in this formula, RW. So your R here is 10 meters. Yeah, 10 meters times your W, 7 pi radians per minute. So this is basically 70 pi meters per minute. That's the exact answer. But approximately, this is 219.91. 219.91 meters per minute. So this is the answer, guys, okay? If ever I was wrong, because yeah, I sometimes I tend to be forgetful. So if I was wrong, please go in here, okay? So yeah, I think that's it. That's it. Okay? Yeah, that is all. So anyways, we're done. That's actually a lot. And now prepare yourselves because what we're going to do next time, is we're going to discuss the unit circle. All right? So, see you soon.